Students, in this video, I'll be talking about an algorithm called as quicksort. Not only looking at the algorithm, we will also be looking at the manual calculation of how the quicksort is getting carried out on a list of elements. This comes under the subject analysis and design of algorithms, and the subject code is BCS 401. Okay, let us look at the technique. Let us look at the technique. The technique follows this divide and conquer. And here, unlike other methods like merge sort, in case of merge sort, what happens is the division or the partition of the array into two parts. It is based on the indexes. Whereas in case of quicksort, the partition happens with respect to the element itself, not with respect to the index. It will happen with respect to the element. Okay, see, in case of merge sort, it will be high and low divided by 2, something like that. Here, it will not be based on the indexes. Rather than we look at the elements itself, and based on that, we do the partition. Okay, we'll look at two examples, one from the model question paper and the other one with respect to an alphabet. Okay, so before I go to the algorithm, okay, let us do the manual calculation here. So that will be helpful for you. Okay. In exams also, they will ask you a lot of manual calculations, so you should know. So I'll take this array. This is the array. I want to carry out the quick sort and arrange them in the ascending order. Okay. So there are many methods to do this. Okay. I will do with respect to this algorithm so that it becomes easy for you to remember. Okay. If you learn the manual calculation and the algorithm, both are of the same type, then it will be easy for you to remember. Okay. So we'll start with the solution, pass 1. Okay. Pass 1. Let me write all the array elements. Initial array elements are E, X, A, M, P, L, E. Okay, I will write their indexes also. So this is 0, 1, 2, 3, 4, 5, and 6. Okay, now let us identify the low and high. Low and high. Low is 0. High is 6, the last index. And we have one element called as pivot. Okay, pivot will tell you where the partition should happen. Okay, it will be the element. Based on that, we do the partition. See, initially when you don't know what it is, it will always be the last element. It will always be the last element. So in this case, the last element is E. This one. Okay, so last element E. Now, let us start the calculation. Okay, let us start the calculation. I'll do the table so that it becomes easy. So we have I, then we have J, then we have an array, then we have comparison, and the action taken. Okay, if you learn this way, it is a bit lengthy, but you will easily get the answer. See, I will be always, see, in the case of an algorithm also, see, this part. See, array of high is pivot, array of high. So A of 6 is pivot. So the last element is pivot. Okay. And I is low minus 1. Low minus 1. See, low is 0. So low minus 1 means 0 minus 1, which is minus 1 initially. Next, you see, for J is equal to low to high minus 1 do. Low to high minus 1. See, in this case, low is 0 to high minus 1. High is 6. So 6 minus 1, 5. So the loop will go from 0 to 5. Okay. And what is the comparison we do? This is a comparison we do. That is, if A of j is lesser than or equal to pivot, okay, if it is lesser than or equal to pivot, if it is, sorry, if it is yes, if it is yes, if it is yes, then it enters the body of this condition. So two statements are there. One is I, you have to increase. See here, I, you have to increase, and you have to swap A of I and A of j. You have to swap A of I and A of j. Okay, that is what you are supposed to do. I hope you have understood. Now, the calculation. Okay, so low, this I is low minus 1. So low is 0. So low minus 1 means 0 minus 1. So it is minus 1. And j will go from low to high minus 1. So 0 to 5. High is 6. So high minus 1, 6 minus 1, 5. Okay. And comparison you have to do is A of j, is it less than or equal to pivot? If it is yes, then you have to increase the value of I, and then you have to swap I and j as in the elements in the position I and j. And if it is no, then no action will be taken. If the condition is false, then no action. So you have to remember this. Okay, then you will be able to do it easily. So let us start. So initially I is minus 1. J will be 0. J has to go from 0 to 5. So initially it is 0. Now let us do the comparison. Is A of j, A of j is A of 0 less than or equal to pivot. So A of 0 is E. See here. So is E less than or equal to pivot. Pivot is also E. So is it less than or equal to E? So E is not less than E, but E is equal to E. See, that equal to condition is also there, right? So this becomes yes. Correct? This becomes yes. E is less than or equal to E. Yes. So what are you supposed to do? If it is so, increase the value of I by 1. So I plus plus means I is right now minus 1. So I will become 0. Okay. So I will become 0. So what I will do is, it was minus 1. Now it has become 0. And you have to swap. Okay. Right now I value is 0 because I have increased I. So A of 0 and A of j is how much? J is also 0. So A of 0 and A of 0. That will be A of 0 and A of 0. You can't swap. The element will be the same, isn't it? So this will be same thing. No change in the array. Okay. Once you have done understood one or two steps, then I'll do it fast. Okay. Next, j will increase 1. Now check, okay, is A of j less than or equal to pivot? So A of 1, is it less than or equal to pivot? So x, A of 1 is x, is it less than or equal to pivot? Pivot is E. Is x less than or equal to pivot? No. So if it is no, no action will be taken. And this remains the same. The array remains the same. Next, j becomes 2. Okay. Now, A of j is less than or equal to pivot. So, A of 2, is it less than or equal to pivot? A of 2 is A. Is it less than or equal to pivot? Pivot is E. Is A less than or equal to pivot? Yes. Correct? If it is yes, what are you supposed to do? Increase the value of I by 1. So this is I is 0 right now. So increase it by 1. So this becomes 1. 0. So it has increased to 1. Now you have to swap. What you have to swap? A of I and A of j. So this becomes 1. So A of 1 and A of 2 should be swapped. Okay, A of 1 and A of 2. So A of 1 is X and A of 2 is A. Okay, so it has to be swapped. So it becomes E, then A, then X, M, P, L, E. Okay, let us do the next step. 3. Okay, 3. So A of j less than or equal to pivot. A of 3. A of 3 is M. You have to look at that. Okay, so here it is. A of 3 is M. Is M less than or equal to E? No. So no action will be taken. So the array remains the same. Then 4. So A of 4 less than or equal to E. A of 4 is P. Is P less than or equal to E? No. So no action will be taken. Array remains the same. Next, 5. J equal to 5. So let us see L less than or equal to E. Is L less than or equal to E? No. So no action will be taken. Array remains the same. Okay. See, you have to do from j equal to 0 to 5. So you have finished A equal to 0 to 5. I is still 1 only. Okay. Now, after you're done with that, your algorithm says something. See, once you're done for all the values of j, you have to do this last step. Okay. Return, so it is a swap array of I plus 1 with array of I. Array of I is pivot. Okay. So you have to swap A of I plus 1 and pivot element. Array of I, which is your pivot. See, I is right now 1. So it will be 1 plus 1. So this becomes 2. And pivot will be now exchange. See here. This is the array. So if I write, so this is 1, 2, 3, 4, 5, 6. You have to exchange A of 2 and pivot. A of 2 and pivot. A of 2 is X and pivot is E. Correct? You have to exchange them. So your array is going to look like E, A. In the place of X, the pivot element will come. Then M, P, L, X. Now you see, this is a pivot. It has moved to somewhere in the middle. Okay. So with respect to this, you have to do the partition. How you have to do the partition? There is another algorithm for this. See here. Okay. If low is less than high. If low is less than high means, it means there is at least one element. If there is at least one element, then only you can do the partition and all those things. See, you will get the partition value, right? Partition value will get from this. See, I plus 1 will give you the partition value. Then one will be array low to pi minus 1, pivot, and the other one is pivot plus 1 and high. See here, I have got it like this. So one part would be low to pivot minus 1. The other one would be pivot plus 1 to high. Okay, so now you have got two parts. So one part is E and A. The other one is MPLX. Now you see pivot has moved to the middle. So can you see that the elements to the left of the pivot, okay, are lesser than or equal to pivot, and the elements to the right side of the pivot are greater than or equal to pivot. Correct? Okay. Now let us do the same thing that we have done on the other elements as well. Let me do on M. I'll now take the new array. Okay. I'll take the new array. So array is now, I'll do the left part first. So E and A. Okay, so low is, let me write low, and so this is 0 and 1 index. So now low is 0, high is 1, and pivot is the last element A. Correct? This is what you will do. Then you will write the values of I, then J. J will go from 0 to, oh sorry, low to high minus 1. High minus 1 means it is 1 here. So 1 minus 1, 0. So J will only run for 0 value. And you have array. Then you have comparison. And you also have action. Okay. So initially I will be low minus 1. So minus 1. J will start at 0. Okay. So let us compare. A of J, is it less than or equal to pivot? So A of J means A of 0, is it less than or equal to pivot? So E, is it less than or equal to A? No. So it means no action will be taken. Correct? So the elements are E and A itself. See, the whole thing will run only for one value of J. So this is done. So after that, do you remember what happens? After you're done? After you're done with this, next I will be increased by 1. I will be increased by 1, and that element will be exchanged with pivot. These two will be swapped. Okay, so A of I plus 1, I is minus 1, so it is A of 0 now. A of 0 and pivot will be exchanged. So A of 0 is E and pivot is A. These two will be swapped. So the list I will get is A and E. Okay. Now remember, pivot was A. Now if I have to divide, nothing is there to the left of the A, but to the right of the A, E is present. But what to do for in that case? You will write pass 3. You will write pass 3, and you will say that in pass 3, okay, here in the right of A, only one element is present, so no need to do any sorting. They will be already arranged, no? Okay, like this. Let us do pass 4. Pass 4. So I've got the right side as MPLX. This is the array I've got. MPLX. The elements are 0, 1, 2, and 3, the indexes. So I'll write the high and low. High is 3, low is 0, and pivot is the last element. So it is X. Okay, now we'll do the same thing. Note that X is anyways in the last position. So if you remember, anything to the left of the pivot should be lesser than or equal to pivot. It is already there. But what does the computer do? Computer will not leave it here, right? When the algorithm executes, it will execute till the very end. Okay, so yeah. So I, then J. J will go from 0 to I minus 1. So 2. Then we have array. Then we have comparison. Then the action taken. Okay, so initially -1 I, j value is 0. Now compare. So A of 0, is it less than or equal to pivot? A of j. Okay. So A of 0 is m. M less than or equal to pivot? No. So no action will be taken. J will increase. Again, A of 1 will be compared with pivot. A of 1 is P. So P less than or equal to X? No. So no action will be taken. Again, J will increase. So L less than or equal to X? So yes, right? L is less than or equal to X. Then what should happen? Remember, what are you supposed to do? Let me write like this. Okay, now what you're supposed to do? Increase I by 1 and swap A of I and A of j. Okay, A of I and A of j. So, yeah, I is right now, I is right now -1. So, I will become 1. 1 second, okay? Just a second. Sorry, here, 1 minute, okay? In this case, yeah, here, see, when you check for m less than or equal to x, m is less than or equal to x, right? So what you're supposed to do is, okay, what are you supposed to do? Increase the value of I by 1. So this becomes 0. Okay, so exchange A of 0 and J of 0. A of 0 and J of 0. So it will remain the same, but that will happen. That exchange will happen. Similarly, when you come here, see P is less than or equal to X, it's a yes. So what will happen? I will increase by 1 and these two, A of I and A of j will increase, they will exchange, but it will remain the same because the elements are the same. It will be P itself. When it comes to A of 3, okay, A of 3 again, see, I is this one. So here it will become 2. Okay, so now M, P, L and X only, because if you exchange also, if you exchange here also, the A of I, A of 2 and A of 2 only, no, you are exchanging. So the elements will remain the same. Okay, so that is what. And let us now see what will happen in the last step. So we have done for j equal to 0, 1 and 2. After this, no action here, no action here and no action. Now you are supposed to do what? After you come out of the loop, increase a by 1 and exchange it with the pivot. These two should be swapped. Okay, so it will be a of 3 and pivot. A of 3 and pivot. See, A of 3 is how much? X. Pivot is what? X. So when I exchange these two, the elements will still remain the same. P, M, P, L, X. This will be the pivot. Now, everything to the left of the pivot becomes one set. Everything to the right of the pivot again becomes the next one. Okay, so MPL will be the values, right? MPL. So let us do the next pass. See, the procedure is lengthy but not difficult to understand. I think as compared to the other procedures, this one is easy to do. Okay, so M, P and L. So this is 0, 1 and 2. So low is 0, high is 2 and pivot is L, the last element. Let us do the table. So j will go from 0 to 1, 1 less than the height, then array, then comparison and action. Okay, so initially I is -1, j will start at 0, comparison. So a of j will be compared with pivot. A of j is m, a of 0 initially. Is it less than or equal to pivot? No. M is not less than L, so no action will be taken. Now j will increase by 1, so it will become 1. So now P will be compared with L, A of 1 and pivot. So again this is no, so no action will be taken. Now what are you supposed to do after this? After this you have to increase the value of I plus 1 and then swap it with the pivot. Okay, so I is right now -1. So this becomes A of 0 and pivot to be exchanged. Okay, A of 0 is M and pivot is L. So these two will be exchanged. So L, P, M, LPM will become the list. Correct? LPM will become the list. Remember, L is the pivot. Right? Now you see to the left of the pivot, nothing is there. To the right of the pivot, we have two elements. Again, repeat the procedure. So pass 6. Pass 6. Now the elements I have is P and M. The elements. So low is 0 and high is 1 and pivot is M. Okay. So I, J. So J will only go to 0 because the high -1 and action. Sorry. Array, comparison and action. Okay. So I is -1 initially, J is 0. Not J of 0, J only. You have tried. This is just J. Now A of 0 compared with the pivot. Is P less than or equal to M? Is P less than or equal to M? No. So no action will be taken. So this ends it. Then you have to do what? Increase the value of I by 1 and exchange it with the pivot. Remember, I is -1. So this becomes A of 0 now by increasing and the pivot will be exchanged. So A of 0 is P and A of pivot is M. So this will become M and P now after the swapping. So remember, pivot was M. So pivot. So only one element is left to the pivot. So now pass 7, you have to say that to the right of the pivot, only one element is present. Only one element is present. So no need to sort. Okay. See, initially, so we'll start from here. So initially, see, we got E. Okay. Then we got A. See, E was the middle element. Then we got A and then we got E here. Then we got MPLX. In that we got, see, MPLX only. MPLX. So X was at the last. Pivot will give you the position, right? Then pivot was L. So that came here. Then M came. Then P. See, steps are more, but very easy to solve this way. So there won't be any confusion while doing any examples. So I have explained with the help of algorithm also. And I think we have another question here. 25, I think I'll do this also. Or I think I'll show you the solution because I've already solved this. So let me show you the solution. So these are the elements, okay? 25, 75, 40, 10, 20, 5 and 15. Okay. And so pivot is the last element. Pivot is the last element. 15. So low is 0 and high is 6. So I will start and sorry, high will start and j will go from 0 to 5 because it is high minus 1. So till 5, then array, then comparison. Comparison is a of j less than or equal to pivot. That is the comparison you will do. Okay. And action, swap or not swap based on the value. So initially I is minus 1, j is 0. You write the elements. Now you compare. A of 0 is less than or equal to 15. A of 0 less than or equal to pivot. Okay. So is 25 less than or equal to pivot? No. So no swap. I have not written here. You're supposed to write less than or equal to also. Okay. Similarly, j will decrease. J will increase. So 1 becomes 2 now. 1 also 75. So 75 is less than or equal to 15. No. So no swap. Next to 40. So 40 also less than or equal to 15. No. So no swap. When it comes to the third element here. So third element is a of 3. A of 3 less than or equal to 15. So a of 3 is 10. So 10 is less than or equal to 15, right? So what are you supposed to do? Increase the value of I by 1. I was minus 1. So I now becomes 0. Okay. Now you swap a of 0 and a of 3. A of 0 and a of 3. Correct? A of 0 is 20. Sorry. A of 0 is 25 and a of 3 is 10. So we have exchange here, you see. J will increase to 4. Then you will compare the element in the fourth position. Fourth element is 20. So 20 less than or 15? No. So next comes 5. J equal to 5. When it comes to 5, it is 5 less than or equal to 15. Yes. So I was 0. Now it will increase to 1. So you will swap A of 1 and A of 5. A of 1 and A of 5. So 75 and 5. So 75 and 5 is exchanged. After that, what are you supposed to do? Because J has now finished all its iterations. Now you will increase the value of I by 1 and swap it with the high value or the pivot value. Sorry. Okay. So what will happen? I is right now 1. So I plus 1 means A of 2. So this is 0, 1, 2, 3, 4, 5, 6. Correct? Now you will exchange the values. So here 15 will come and here 40 will come. Correct? So 15 has come here and 40 has come here. So this one is pivot. So one list will be 10 and 5. The other list will be these 4 elements. Okay. Now you will do on 10 and 5. So 10 and 5. So low is minus 1. Sorry, not it is 0. I is minus 1. Low is 0. High is 1 and pivot is 5. So initially I is minus 1. J is 0. So you'll compare A of 0 less than or equal to pivot. So 10 less than or equal to pivot. No. So no swap. After that, what you will do? You will increase the value of I by 1. So I plus 1 is 0 plus minus 1 plus 1. So it becomes 0 and 1. So 5 and 10, they both will get exchanged. Correct? Next, you will do the same procedure on this right side element. So 25, 10, 75, 40. Okay, so you can see this. Okay, take a screenshot if you want and do the calculation and check if you're getting the correct answer. Okay, so pass 4, you'll get like this. Pass 5 and pass 6. Okay, so this is what quicksort is. Quicksort is an algorithm that is following the technique of divide and conquer. It will divide the array into two parts based on the element called as pivot. So deciding the position of the pivot, we use the two algorithms. One algorithm is for finding the pivot and the other one is used for partitioning based on the pivot. So usually in the quicksort, when they'll ask you to write the algorithm, then you're supposed to write both the algorithms. One is your partition algorithm and the one is finding the pivot. Okay, so I hope you have understood. Practice for this example and take your own elements and try. Okay, thank you so much.